The next example is still in the same topic because I just want to get used to with this type of problem. And also, as I mentioned the lambda that we are just talking about from the last example, actually it is called the eigenvalue. This example is just asking us to find the solution of the linear system. And this linear system, again, we have two dependent variable and one independent variable, as you can see, x1 and x2. Yeah. So, in order to find the solution of this linear system, you've got to assume the x1 and x2, and we just assume that x1 is equal to k1 times exponential lambda t, and x2 is equal to k2 times exponential of lambda t. The next step is just that plugging whatever we assume back into our linear system. And when you take a look at our linear system, you would see the first derivative terms of x1 and x2. So from that, before we plug in x1 and x2 into the linear system, we should do the first derivative of these two solutions. So the first derivative of x1 by t is equal to k1 times lambda times exponential of lambda t. And the first derivative of x2 by t is equal to k2 times lambda times exponentials of lambda t. When we see that, we would now we're ready to plug x1, x2, and the first derivatives of x1 and x2 into our linear system. By plugging that, we would get the first and the second equation. So from this, you would see that both equation 1 and 2, we have the terms of exponential of lambda t in every term. So from that, I said that I will take exponential of lambda t to divide equation 1 and equation 2. By doing that, we would get these two equations. And then the next thing, now we have only k1 and k2, right? And then we have the lambda or eigenvalue as the coefficients of k1 and k2 on the left hand side of the equation. From that, I just move the k1 lambda to the k2 k1. And also I just move the k2 lambda to the other side, which is the minus 2k2. And from that, I would get equation 3 and equation 4. From equation 3 and equation 4, I can write down as a matrix. I would get the terms of the coefficients of k1, k2, and then from that, I would be able to write out the characteristic equation. And the characteristic equation actually is just the determinant of the coefficient terms of k1 and k2 and set it equal to 0. This is a 2 by 2 matrix. The way to find the determinant is just that you do the product of the 2 minus lambda and minus 2 plus lambda, plus the term minus the term of the product of 1 and minus 3 here. And then we do rearrange this equation, you get lambda square minus 4 plus t equal to 0, minus 4 plus t equal to minus 1, so you would get lambda square minus 1 equal to 0. So you would find true value of lambda, which is what? What is the true value of our lambda? Our eigenvalues. Okay, -1 and +1. Minus and +1 is a real number and it is unrepeated, so it's still in our case 1. So from this, the next step of us is just finding the value of k, right? We would get two sets of k. The way that we would get k is by plug the value of lambda into either either equation 3 or 4. I will pick equation 3. First, I'm going to put the lambda equal to -1 first. When lambda is equal to -1, what do we get? 3k1 minus 3k2 equal to 0, or k1 equal to k2. By that, I would assume k1 is equal to 1, then k1 and k2 would be equal to 1. So the first set of the solution is x1, x2 equal to 1, 1 times exponential of minus t. Just listen first and then I'll let you taking a note later. Just listen carefully for the method of solving this problem. Okay? And then we plug the value of lambda equal to 1 into equation 3. Now take a look at our equation 3. If lambda equal to 1, what do we get? k1 is equal to 3k2. When k1 is equal to 3k2, so that means k1 is equal. And then we assume our k2 equal to 1, then we would get that k1 equal to 3. Okay. Then our set 2, the second set of the solution would be x1, x2, 3, 1 times exponential of 3, t, sorry. So our general solution would be this equation, x1, 2, c1, 1, 1, exponential of minus t plus c2, 3, 1, exponential t. And that